So this is my second video on chapter 12, which is actually a lot of it is on chapter 11, which you didn't really have to know to do the chapter 11 problems, which is kind of weird, but you do need to know to do the chapter 12 problems, which are much, I shouldn't say, well, kind of harder, more interesting. But it's all really good stuff. So the thing we need to focus on here is, what is this letter E? The natural exponent, which is a good letter for it, so it's E for exponent, and it is like 2.71828, and it goes on forever, just like pi. A lot of people think that it's actually a more fundamental number than pi. It's this amazing number. So where does it come from? And like they mention in the book, which you should read, they give lots of good examples. One way to see where it comes from, there's lots of ways, there's no one right way to figure out E. But one way is to look at interest rates, like with money, which is always fun to look at money. So here's the thing. Let's say we call P the amount of money that you have, and it's called P because it's related to the principal, which is the initial amount of money you have. If you put $1,000 in the bank, your principal is $1,000, and then it gains interest on that. So that's called P0 because that's the amount you have at time 0. The principal you have at time 0. So the amount you have in the bank is the principal, what you put in, plus some money that you get from interest, which is usually some percent. Let's call it A percent of the principal. So for example, let's say you put your money in the bank at 10% interest rate. So A would be 10%. And so then the amount of money you have after 1 year is, let's say you put in $100. So you have $100 in the bank. So the amount of money you have is your 100 plus you have 10% of 100, which is $10. So you have $110 at the end of the year because you got 10% on your money. So, okay, that's okay. But that's really not quite fair, because what are they going to do? At day 366, they dump $10 in your bank account. What about if you take it out 1 day early? You don't get any interest? So it's really better if they give you interest all the time on your principal, because then you're gaining interest on interest. So let's say they give you interest 4 times a year. Then each time, instead of giving you 10%, they give you 2.5%. Which makes sense, but you get it 4 times a year. So after the first quarter of a year, 3 months, the amount of money you have is your $100 plus 2.5% of $100, which is $250. I made the math easy on myself. So that's obviously $102.50. And then the next time, 3 months later, you look in your bank account, and now it's $102.50 plus 10% of $102.50, and that is what, $1.25, I think. That's 2%, take 10% of that, right over here. So okay, not very much, $1.025 we're going to add onto there. And how did I get 250 there? Oh yeah, sorry, 2.5%. Sorry, I'm messing with that. Yeah, 2.5% of that, which I don't want to do that math in my head. I knew something was messed up there. But you can keep doing that. You do that 4 times, and you're going to have more money because you're getting percents of your principal. So you're going to end up with more money than $10 because you're getting interest on your principal, on the money you've already gotten in interest. Okay, let's make the math a lot easier because I was getting all jumbled up there. And let's say you get 100% interest, which means you double your money. Okay, so let's say you put $100 in the bank, and if it's compounded once a year, at the end of the year, you have $200. But we know that's not exactly fair, because what if you take it out 1 day early? You still only have $100. You should be gaining interest on your interest. So let's say if they did it again 4 times a year, then you would get 25% interest 4 times a year. So after 1 month, after 3 months, 3 months, 4 times a year is every 3 months. Then you would get 25% interest on $100, you'd have $125. And after 6 months, you would have 125 plus 25% of that, which is hard math. It's going to be more than $25 though. So let's say it's 30, and I'm making that up. So let's say it's $155, and you keep going like that, and you're going to have more than $200 at the end of the year. And let's actually do this right. Okay, so you would have 125 plus 25% of 125, and I'm actually going to do all this just for this one. 0.25 times 125 is 31.25. So you would have that much more, so add that to 125, and we get 156.25 after 6 months. So in 9 months, we would have 156.25 plus 25% of 156.25. So I'll do all that. And I get 195.31, and finally in 12 months, and I'm writing pretty messy there, we have 195, and really it's 0.3125, I might as well keep all my decimal places, 0.3125 plus 25% of all that, 195.3125, which is 244.14, which is a lot better than $200. So if they give you interest 4 times a year instead of once a year, it goes from $200 to $244. Now, it would be even better if they gave you interest every month, or every day, or every second, or every millisecond. And if they gave you interest infinitely fast, so we go down to the 0.00001 seconds, then the most money you could possibly make was $271.828 ... which is E times 100, because we started off with $100. So E is a number that you get if you start off with $1 and you compound it continuously. They call that continuously. Infinitely number of times a year, continuous compounding. It turns into $2.78 and 0.1828. That's how much you could, that's the best you could do at the end of the year if you get 100% interest rate and it's compounded continuously. So that's where the number E comes from. It's continuous compounding, and the best you can get at 100% interest rate if they give you interest every single microsecond, really infinitely small time. Okay, so there are 2 formulas you need to know then for how this works. If you do what we just did, then the principal, how much money you have, is how much you put in. The amount of money you have is the principal, how much money you put in, P0, how much you have at time 0, times 1 plus their interest rate, which is R, divided by the number of times you compounded a year, to the number of times you compounded a year times time. And we're typically going to do this, you can do it any time you want, but normally it's annual. So you'd say that R is like the annual interest rate, the rate of growth. So annual growth rate, because it might not just be money, it might be population or something. Annual growth rate, which is the interest rate. And it is not a percent, that's in a decimal. So when you do the math equations, you don't use percents, it's a decimal. And then N is the number of times a year, number of times you compound it, you get the interest annually. So we just did 4 times, so N would be 4, and you raise that to the 4 times the amount of years that have gone by, or maybe it's half a year or whatever, that's what T is, the number of years. N would have been 4, and as N goes to infinity, as we compounded an infinite times a year, then we get the amount of money you have, or the population of goats you have, or whatever it is how many you started off with, the population of goats you start off with, or the amount of money you start off with, times E to the RT. And that's where this E comes in. It's the natural way things grow, where R is the growth rate if it's compounded continuously. So these are the 2 formulas, and this is for continuous growth versus only growing 4 times a year or 10 times a year or something. Continuous growth. So those are the 2 formulas we're going to be using a lot. This is if they pay you at the end of the year or something, then n would just be equal to 1, which is not a very nice way to do it. And here they pay you every single, nanosecond, but even faster than that. Infinitely times number of year, we have that formula. And those formulas are going to be what we're using to solve a lot of problems in chapter 12. So the next video, I'll do some example problems using this stuff and show how cool it is to be able to solve these things.